Hi everyone, what we're doing today is solving simultaneous equations graphically. Now what that means, because yesterday we did it algebraically, but if we're going to solve it graphically, it means that we've got to sketch the graphs of this one and find out the point of intersection. So let's start off with this y equals 5x plus 2. If we're going to sketch y equals 5x plus 2, one of the ways that we could do it is draw x and y a table of results and do 0, 1, 2, 3. And to find this coordinate, I do 5 lots of 3, 5 lots of my x number, plus 2, so that would be 17. This one would be 5 lots of 2 plus 2, 5 lots of 1 plus 2, 5 lots of 0 plus 2. But as we're preparing for A-level maths, we're going to have a look at a slightly quicker way of doing this, and that's using y equals mx plus c. Now, using this thing here, we've got m, which is the number in front of the x, is 5, so that means the gradient is 5. We'll come back to that in a second. But this plus c, the y-intercept is plus 2, which means that this graph here goes through at plus 2. Now the gradient is 5, which means every time we go across by one step, we're going to go up by 5. So if we're at 2 here, take one step across, then we're going to go 5 steps up. So that's going to be 1, 7. And when we do this, we only need 2 points in order to draw a line. So then what we do is we join them up. Obviously, you guys will be able to do this on graph paper, so be far easier if you do it in your books or on graph paper. I'm going to need to do it freehand. So let's try that there. Goodness, that was awful. There you go, third time lucky. Okay, so hopefully you'll have a little bit more joy than I did just there. But we get the idea. So it goes through 0, 2 and 1, 7. Then we're going to sketch this one, x plus y equals 5. Now what we could do is we could rearrange this to have y equal, if we bring the x onto the other side, minus x plus 5. So we know it's going to go through at 5, and then for every one you go across, you go down by 1. And if you want to do it that way, that's absolutely fine. So that's rearranging it so it's in the form y equals mx plus c. And if on this exercise you want to do that, absolutely fine. I find with these graphs is a slightly easier way to do it. Now this x plus y equals 5 means that my x coordinate plus my y coordinate adds up to 5. So if I say my x coordinate is 5, my y coordinate is going to be 0. So that coordinate is going to be 5, 0. So that's that coordinate there. Or if my x coordinate was 0, 0 plus something makes 5, so 0 plus 5 makes 5. So 0, 5 is another coordinate, which we said that it's going to be anyway when we did the y equals mx plus c. And we could have 3, 2, because 3 plus 2 is 5. So 3, 2. Either way though, we end up drawing this line here. And then what we've got here is we've got a point of intersection. Now the coordinates of that point of intersection is going to be the solution to these equations. So here, to me it looks roughly, it's halfway between 4 and 5 and probably halfway between 0 and 1. So I'm going to say that I think the coordinate is 0.5, 4.5. But I think that, I mean obviously it's tricky for me to tell because I've got this whiteboard here and it's not got any grid lines on it. So it's worthwhile trying to check. So let's see if it works on both these. So 0.5 plus 4.5, yeah, that does make 5. Right, so y equals 5 lots of my x number plus 2. So 5 lots of 0.5, well 5 lots of 5 is 25. So 5 lots of 0.5 is 2.5, plus 2 is 4.5. So if I put 0.5 in here, I'm going to get 4.5 out. So yeah, brilliant. Therefore this is the correct coordinate, and that's how you do that one there. So that would be a slightly easier version because they are two linear equations. Now what we're going to have a look at here is when we've got a linear equation and a quadratic equation. And remember the quadratic equation from the lessons that we've done previously are curves. So the next example that we're going to do is to solve y equals x minus 4 and y equals x squared minus 4x plus 2. Okay. So if we then sketch this, I'm going to have my y-axis going up to 3. So 1, 2, 3. And because it's going to be a parabola, it's probably going to go down below the x-axis as well. So I'm going to go down to minus 4. And just before I get to it, see if you can guess why I've gone down to minus 4. And then I'm going to want to go from minus 1 here across to 4. So 1, 2, 3 and 4. Okay, so if I sketch this one out first, the fact that it's minus 4 there, that means that's where it's going to go through my y-axis. And the fact that it's 1x means every time I go across by 1, I'm going to go up by 1. So minus 3, 1. Minus 2, 2. Minus, so 2 minus, sorry, 1 minus 3, 2 minus 2, 3 minus 1, 4, 0. So it goes through like that there. Then we've got y equals x squared minus 4x plus 2. So what we're going to do with this is we're going to try and sketch it. So we know that it's going to go through just like we did the other day. So we know that it goes through at plus 2. So we're going to go through there. Now if I set this equal to 0, 0 equals x squared minus 4x plus 2. I'll try and factorise that. I'm going to try and find numbers that multiply together to make 2, so that's only 1 and 2. If I put 1 and 2 there, I'm not going to be able to make minus 4x. Now if that's the case, sometimes it means that it doesn't go through the x-axis, sometimes it means it goes through between numbers. So what we're going to do, instead we're going to find out what the minimum point is. As soon as I find out where I put my cloth. Right, so to find out where the minimum point is, we're going to do completing the square. So I'm going to do y equals x minus 2 squared. Then we take away 2 squared, so take away 4 and have that plus 2. So y equals x minus 2 squared minus 2. So if you remember about what this means then, to find the minimum point, I know that the minimum point is where this thing equals 0. So it's going to be minus 2. But what value of x makes this bracket equal to 0? It's going to be 2. So if I put 2 into this, 2 minus 2 is going to be 0. 0 squared is 0, take away 2. So 2 minus 2 is going to be the minimum point. And we know that it looks like that. So what we've actually done is we've found out a point where they both go through. That means my curve is going to go through, it's going to look something like that there. Now, once you've done that, we've got our first solution, which is 2 minus 2. And then how do we go about finding the other solution? Well, we have a look at where we think it looks. And if you've done it accurately, we should find that it goes through roughly here. I mean, mine doesn't, but mine's not the best drawing, so it should look something like that. And if we check that, so we think 2 minus 2 is definitely 1 because they both lie on it. Let's check 3 minus 1. So if I put 3 into this, x is 3. So y equals 3 take away 4, which equals minus 1. So 3 minus 1 works for the straight line. But does 3 minus 1 work for this one? So if we put in x as 3, y equals 3 squared, take away 4 lots of 3, plus 2. So y equals 9, take away 12 plus 2, y equals minus 1. So 3 minus 1 works for both of them. So the whole thing with this, and it's a lot easier once you've got it drawn on square paper, is you sketch these as best as you can. And if you're not sure about what this one's going to look like I got my initial one for the curve a little bit further out, you can actually sketch this out and do the table of results. So you can do x and y, minus 1, 0, 1, 2, 3, and just substitute in values to this to see what you get. So then once you've sketched both those out, you find out the point of intersection, and that's going to be your solution. So the solutions overall, now that we've got this, are going to be x equals 2, y equals minus 2, which was the coordinate 2 minus 2, and we got x equals 3, y equals minus 1, which was the coordinate 3 minus 1. Now if you have a crack at this worksheet, again, email me with any questions that you have, but well done.